Hey guys, this is Eddie. Welcome to another vectors lesson. Hopefully you guys are getting pretty good at it now, and a word problem like the one that I'm showing you shouldn't take you guys any longer than 5 to 10 minutes. So have a go at it and come back when you're done. Okay, so the first thing that you should do when you see a word problem is to draw a diagram. So I'm going to draw a river. So this is a river, and I'm going to draw a vector representing the current of the river, which is 5 kilometers per hour. So this is the velocity of the vector, the velocity of the current, and it's moving to the right. And I have a boat which is traveling at 15 kilometers per hour south. So draw a little picture of the boat, people rowing the boat perhaps, and it's traveling 15 kilometers per hour south. So it's going south, which is directly downwards at 15 kilometers per hour. Now we want the net velocity of the boat. So how we should do this is we're going to do it by drawing the resultant vector. Okay, so we have a boat that is moving directly downwards at 15 kilometers per hour. So 15 is the magnitude and the direction is downwards. And then we also have the vector added onto it, which is going directly east 5 kilometers per hour, which is the current. So you can do this either way. You can either draw the 5 kilometer per hour east first and then add on the 15 kilometers per hour downwards, or you can do it this way. It should give you the same resultant vector, which is this line here. That is the result. And what does the question want? It wants the net velocity of the boat. The net velocity of the boat is this resultant vector. So let's call this velocity, let's call that vector u. Okay, so u is equal to the net velocity of the boat and the first thing we want is the magnitude of u. Okay, so how do we find the magnitude? Well, we're going to use Pythagoras. So we're going to square root 15 squared plus 5 squared, because this is a right angle triangle here. So putting that in the calculator, the square root of 15 squared plus 5 squared, and the answer is 15.81. So the magnitude is 15.81 kilometers per hour. And we also need to know the direction of the velocity. So if you imagine this is the origin, okay, because the boat is starting over here and we have the Cartesian plane or the compass and this is the north, this is the east, and we need to know this angle. Okay, the angle from the horizontal to where vector u is. So this is our right angle triangle. Right, this is our right angle triangle. This is a straight line. And in order to find theta, we have the opposite side, which is 15, and the adjacent side, which is 5. So theta is equal to inverse tan, opposite over adjacent. So it's inverse tan 15 over 5, and putting that in your calculator, so inverse tan, which is the same thing as arctan, by the way, when you type it in Microsoft Mathematics, 15 over 5. And if you're using Microsoft Mathematics, just make sure that you're on degrees mode. Press enter. The answer is 71.6 degrees. And if you want the bearing from the north, you're gonna have to add on another 90 degrees. So true bearing is 90 plus 71.6, which is 161.6 degrees true. So you can say the answer to question A. Alright, question A. The net velocity of the boat. So the boat is traveling at a velocity, at a net velocity of 15.81 kilometers per hour in the direction (161.6 degrees true). Right, that is the actual velocity of the boat. Right, it's actually moving in this direction instead of directly south, right, because of the current. Okay, so the next thing is, if the boat is 600 meters wide, how long will it take to cross the river? Now, keep in mind that the boat is still moving downwards at 15 kilometers per hour. So, if it's still moving downwards at 15 kilometers per hour, right, even though there is a current making it move to the east, right, so this is where the boat is heading, right, because the current is moving it to the east. When you are looking at it vertically, okay, so if you're looking at the vertical speed or velocity of the boat, it is still moving downwards at 15 kilometers per hour. So the vertical distance that it has to travel to cross the river is how many? 600 meters, which is 0.6 kilometers. So when you want to calculate how long it takes to cross the river, you're only looking at the vertical axis. So the answer is going to be velocity equals distance over time. Velocity is 15. Distance is 0.6. We don't know what t is. So t is equal to 0.6 over 15. And the answer is, according to Microsoft Mathematics calculator, 0.04 hours, right? Because we have speed is measured in kilometers per hour, and the 0.6 is measured in kilometers, so t is in hours. So 0.04 hours, if you want to multiply that by 60, the answer is 2.4 minutes. Okay, so it takes the boat 2.4 minutes to cross the river, which is pretty quick. Okay, thanks for watching, guys. See you next time.